About constant proportionality, but before we do so, let's talk about simplifying expressions. Simplify this expression. There's two ways you can do this. You can use algebra tiles by drawing it, or you can use the mathematical using distributive property. So we have 5x's. Each one of these rectangular bars represent an x tile, and you have 4 groups of 2 plus x. So this represents 2 plus x. 2 squared units, which are positive, and you have an x. But we need 4 groups of those. 1, 2, 3, 4. So how many x's do you see here if you combine all the x's together? I see 9 x's. How many square units do you see? I see 8 of them, so it's 9x plus 8. Be aware, do not combine the x's with the square unit. They're completely different entities. These are the x, these are the unknown, 9 groups of some unknowns, and these are positive 1. And we know what those are. However, what if you do not want to do it this way? What if you wanted to solve it this way? So we know we have 5x plus, what's 4 groups of 2? 4 groups of 2 is 8. What's 4 groups of x's? 4 x's. So if we combine the 5 x's with the 4 x's, we get 9x plus 8. Let's go to our next slide. So Mr. Joe's car can travel about 30 miles on 1 gallon of gasoline. Make a table and a graph to show the distance traveled after 1, 2, 3, and 4 gallons of gas. Is there a direct variation? If so, state the constant proportionality. Constant of proportionality is saying that you have a ratio that's comparing two quantities, two numbers, and it's the same ratio from one part of the table to the next part of the table to the next part of the table to the next part of the table. So it shares. So if you break it down, if you break down this ratio or any of the ratio, they should all should equal the same simplified ratio. For example, 1 gallon of gas takes 30. I can drive 30 miles with it. 2 gallons of gas, I could drive 60. 3 is 90. 4 is 120. So let's graph this. 1 gallon gas is 30, 2 is 60, 3 is 90, 4 is 120. I'm going to connect the dot because as I am using gasoline, I am continually driving. It's continuous. So this is my thing. So is there direct variation? That means, same thing as constant proportionality, is the ratio for each one of them going to simplify to the same one. So this is the parent ratio. This is one we started with. Will 260 or 60 over 2 or 90 over 3 or 124 will it simplify down to 30 over 1? Let's see. I was able to drive 30 miles with 1 gallon of gasoline. If I drove 60 miles with 2 gallons of gasoline, can I break this down? Let's see, what can I break it down? I divide both numbers by 2, so it's 30 miles for 1 gallon of gasoline. Is it the same? It is. So there is a direct variation. I mean, these two are directly related to each other because they share the same simplified ratio. So if so, state the constant proportionality. It's 30 miles for every gallon, or 30 mpg. So in next one, let's keep on going down our table. Let's make sure we were able to drive 90 miles with 3 gallons of gasoline. If you broke this down, divide both numbers by 3, you get 30 miles for 1 gallon of gasoline. Is there a direct variation? Are they directly related to each other? They are. So what is the constant proportionality? 30 miles for every gallon. So is there another way to use it? To find the constant proportionality, you use the formula K equal Y over X. K is a variable. It stands for constant. You would think they would have used the letter C, but I don't know. Someone decided to use K. So K stands for the answer to a constant proportionality. Y is the Y value, X is the X value. So we go back to this table. This is the X, this is the Y. The Y value was 30. The X value was 1. That is why the constant of proportionality is 30 over 1. If you look at the next example, we go back to example, 60 miles, 2. If you broke this down, it breaks down to 30, simplify it, it goes to 30 over 1. So the constant proportionality for that table, that problem, that graph is 30 over 1. Or another way to say it is 30 miles. It goes up 30 miles for every gallon of gasoline. All right, let's go to this one. The number of miles traveled varies directly with the number of hours traveled. Find the constant proportionality for this graph. So what can you tell me about this graph? What is happening? It seems like for every hour, you go 60 miles for every hour. Let's see. 60 miles in 1 hour. This one is 120 miles in 2 hours. This is 180 miles in 3 hours. They say that these are all related somehow. Are they all related? Let's see. 120 over 2. If I break that down by dividing by 2, will it become 60 over 1? It does. What about 180 miles for 3 hours? If I break this down by divided by 3, it becomes 60 over 1. So the constant proportionality is, according to this graph, is 60 miles for every 1 hour, 60 over 1. That is the constant of proportionality. So you're saying, are they all related? Are they all directly related with each other? They are directly related with each other. And if we simplify every one of these again, a ratio is comparing two numbers, the Y value and the X value, it breaks down to 60 over 1. Let's go to the next one. So looking at this table, X and Y, which table, find the constant proportionality for each table. So let's start with the first one. 10 to a 5, a 20 to a 10, a 30 to a 15, a 40 to a 20. What is it? How is it related? How is the Y related to the X? Let's see. K equal Y over X. Well, Y is 5, X will be 10. If Y is 10, X will be 20. That all simplifies to 1/2. So the ratio is 1 over 2, or the constant proportionality is 1 over 2. The second one, how is 15 related to 3, 30 related to 6, 45 related to 9, 60 related to 12? Let's see. Again, constant proportionality is Y over X. 15 over 3 is 5/1. 30 over 6 is 5/1. So it is 5 over 1. Do you notice how I am using two ratios and breaking it down? Because I just want to make sure that this is directly related. Because if I only did one ratio, the first one, 15 over 3, maybe they trick you, could be, that these are not related. So you would think that are all related, that the Y value is 5 times greater than the X value. It is for each one of these. But just make sure you do at least 2 of them, a minimum of 2, just to make sure, to guess and check. Next one, how is 21 related to 7? How is 42 related to 14? 63 related to 21? 84 related to 28? If you break it down, divide by 7 is 3/1. This one, break it down, 3/1. So relationship is 3/1, or 3. And last but not least, how is 20 related to 5? How is 40 related to 10? Divide by 5 is 4 over 1. Divide by 10 is 4 over 1. So the relationship is 4 over 1. And next one. Determine whether each relationship is a direct variation. If so, state the constant proportionality. That means directly related. direct variation. Is this ratio directly related to this one? Is it related to this one? Are all these ratios related to each other? So, again, constant proportionality is k equal y over x. How is 180 related to 6? How is 240 related to 8? How is 300 related to 10? I'm going to use 300 over 10. That's easy numbers. Divide by 10, that's 30 over 1. This is easy too. We just did this question. Divide by 6, this is 30 over 1. So they are all related. So the relationship between the y value and the x value is 30 to 1. So you multiply by 30 to get this, multiply by 30 to get this, multiply by 30 to get this, multiply by 30. That is the relationship, the constant proportionality. Number 5, how is 82 related to 10? 83 related to 11, 84 related to 12. I don't think they're related. If you divide both of these numbers, it'd be 8.2 divided by 10, 8.2 for 1. And I know if I divide both of these numbers, it's not going to be 8.2. So they are not related at all. If you broke down 8210, it's not going to be, and you broke down 8311, they will not share the same ratio. So they are not related. Number 6, what about the next one? 1,500 to 6 payments. Is it related directly? Does it have a direct variation? Is it directly related to 2,750 for 11 payments? If you broke this down, will they have the same dollar amount per payment? So what's 1,500 divided by 6? I have no idea. It goes in $250 for one payment. Is that related to this one? So the relationship here is 6 times 250 is 1,500. Will 11 times 250 make 2,750? If I divide 2,750 by 11, I get $250 also. So is there a direct variation? Are they related? Is this ratio, is the first ratio related to the second ratio? They are related to each other. So it's $250 over 1, and that's the relationship. And last but not least, a ball weighs 15 pounds on Earth and 5.7 pounds on Mars. So as you can tell, on Earth, there's more pressure than on Mars. What is the constant proportionality between the weight of an object on Mars and Earth? So what's the weight on Mars? 5.7 pounds. What's the weight on Earth? 15 pounds. So I would like you to find this ratio here. You simplify this. Let's see. So I would like to break it down. I would like to break this down. I would like to know what's the weight on Mars to 1 pound on Earth. So how do I do it? So I break it down. I have to divide by 15. Divide by 15. What's 5.7 divided by 15? Can 15 go in 5? No. Can 15 go in 57? 3 times. That is a remainder of 12. I need to get rid of this remainder, add a 0, bring it down. How many 15s go in 120? 8 times. So there are 3,800 pounds on Mars for every 1 pound on Earth. That is the relationship here. So that's the constant proportionality. So if I have 2 pounds on Earth, double it, it'll be 16 here. It will be 7,600 pounds on Mars. And so this is a direct variation. These two are related to each other. All 3 of these have a direct variation. They're all related to each other. But if you broke it down, the simplified ratio is 3,800 for every pound. So this is constant proportionality. Again, constant proportionality is when you have a ratio, the y. You have 2 ratios. It's when you have ratios that all share They're all constantly the same. They're all related to each other. And so to find it is k equal y over x. So you find a y value and the x value, and then you have to simplify it.